Okay, first, thank you for the organizer, especially to Ralph, because he invited me to speak about this topic. And okay, thank you everyone. So today I want to talk about agave. Perhaps you didn't hear about this kind of plant, but of course you hear about tequila. Yes, so tequila comes from this plant called agave. So in Jalisco, we have a town called Tequila, and close to this town, we can put these kind of plants, and it's a whole industry in Mexico, especially in Jalisco. So let me put the outline of the talk, a short introduction. Of course, the team that we work in this project, the method, the results, and the conclusion will be in the last part. So this is how it looks like the agave crop. I mean, in a simple way, looks like blue. They call this is color like blue, some green like that. And we want to detect this crop, but in a special way. So agave is perhaps the most emblematic crop in Mexico, at least in Jalisco, and is used for produce tequila. Yes, and for instance, in 2013, was approximately around 90,000 hectares of agave, and around 200 millions of plants. Yes, but this is constantly changed because the agriculture could be changed the plants, or more people want to get the agave. So this is an strategic information for whole the state, because the price could be changed a lot, and this could be have a big a social impact in the Jalisco. Yes, so in addition, it's important to keep an eye, because some agave could be crop in the natural resources areas, and we use to detect or to monitoring the agave crops, we use deep learning. Yes, actually computer vision to do that. And we use a remote sensing approach. This is a very difficult approach in the sense of the spatial resolution. And we use mostly two sensors called Landsat 8 and Sentinel-2. This had a big problem with the young tequila agave, because it's almost invisible to the remote sensing scale. Yes, and some people ask about why don't you use some kind of drone or these kind of things. Yes, it could be useful, but only for small areas, because we want to check all the state in a year. Yes, so this is an example of what we're talking about. This is, for instance, the red one is a kind of agave. The other red is another kind of agave. This is a bosque, forest, I'm sorry, another kind of land cover. Yes, so this is a very actually it's a difficult problem, an open problem in the research area. Yes, so let me explain something about the Jalisco. Jalisco is called, this is in Mexico, it's in the west side, and it is known as the Silicon Valley of Mexico. Yes, because we have a lot of companies like IBM, Intel, and not only the manufacturer companies, they also have some labs, some PhD human resources working on that. We have research centers, universities. So in this ecosystem, in the center of this ecosystem, there is the government of Jalisco try to promote this ecosystem. And inside of the government where I work, there is this, my boss, Mario Arauz, who is a kind of CTO of the government, and try to get all the, I don't know how to say, the technology inside of the government. And this other part of the government try to connect with all these partners outside of the government. Yes, so we try to give the state-of-the-art technology inside of the government. And we work in this project, my boss, Raúl Nanclares, my partner, Abraham Sanchez, and me especially. But there is another team members who works in ethics, data science, and a lot of these kind of things. And of course, we have some collaboration with other parts of the government. Yes. So to make a deep, to create a model of deep learning, we need data, labels, and a lot of computational power. Yes. So this is how looks our data, and perhaps this kind of areas here could be Agave. Yes. So we use this worldview 2 and 3 imaginary. Mostly this kind of representation of the image, RGB and infrared. Yes. So this is a huge amount of data, and we try to work with this kind of data in this way. So to train our model, we need labels, but the labels in a certain way is not the same a label for a human for a deep learning model. Yes. So at the beginning, we get these kind of labels, or only selecting the crop, and then we see that the model don't know how to handle the trees or certain areas. So we need to do a kind of fine tuning of the label. Yes. And we make this strategy to do that. We get this raster, and we make a grid representation of this raster, and then inside of this raster we crop every make patches of 256 by 266 pixels, and we keep these chunks to the model. Yes. In pairs with the image and with the label area. Yes. So we use these kind of models, mask RCNN and UNet. This is a well-known CNN based on ResNet 50. And we make a documentation, this kind of tricks to improve the accuracy. And we train both architectures in order to get some models, and we try to get this. And the final result looks like this. This is the agave, and this is how this yellow side is the segmentation of the agave. Yes. So this could be the resume of the main challenge and solution that we have. First, we had a lot of nosy and coarse labels. because inside of the area we can have water bodies, trees, farms, and other wells that we don't, is not agave, yes. So we try to make a fine grain labeling. The other problem is the image quality, because it's not possible to see in the first years the agave, and it's a relatively small training data set. And if we have that in deep learning, this is a huge problem, because it's not easy to generalize the model, yes. And we have to handle huge images. For instance, around 10 gigas per image, I'm sorry. And we try to handle this using high performance computing on premise, IBM with 4 NVIDIA B100, yes. Yes, so this is the results. This is how it looks, the segmentation results. And I want to highlight that this kind of image never seen by the model, yes. So if you can see that they segmented the trees, the roads, and other things that we want to do it. And we start to use these segmentation results to validate the labels, the previous labels that we got from the humans, and then the humans only check if the label was right or not. Yes, this is another kind of results that where, if you see here, there's some areas with out of agave. That's because of perhaps some illness of the plant, some kind of things. This is a work that we need to improve. But even in these kind of scenarios, we have good results with the image. If you see, they select a different kind of area, even in the middle of in the middle of a kind of forest. Yes, we make a kind of improvement when we label with the CNN, then the human in the loop make the correction, and then train again from scratch. And we got very good results. For instance, this is the first approach that we have. I'm sorry, I don't know why it's moving this way. Okay, this the blue one, and the other one is the new results. This could be seen as improvement. Yes, this technique is called active learning. We use this to improve the results, and we get this. So working together, the artificial intelligence and remote sensing experts, we got time reduction about 10 times than the humans. And we create so far a new data set with better labels. Yes, this is the status of the project. This is how we can measure the performance in numbers in the two approaches. The average precision is 0.50. This is actually a very good result because some of the mistakes is related with the small areas that we can quit with another kind of post-processing project. And in the case of UNET, we have a better performance, but we got some errors in the implementation. Yes, so this is validation results. We need to make a test with that. We need more data to handle this. Okay, So the conclusion, we have developed a powerful tool to monitoring agave stock, and we use deep learning to improve or to make fast the labeling process, and we reduce the expert validation time by a factor of 10 at least, and the model is not finished yet, and we need to validate the results and with more data. We believe that these results could be improved if we get more data and could be used in a future to predict the stack of the agave, because this plant usually takes around 7 years. So if we detect the crops, for instance, from the year 3, we can make a projection about how in 4 years how much the tequila or agave will have. Yes. I believe that this is all. Thank you, everyone, for hearing me. And I don't know if we have questions or something.
So any questions from the audience? I have a few questions. I found it pretty fascinating. How do you capture the image? Is it satellite or?
Yes, the input image are public images from 2 sensors called Landsat 8 and what is the other name? And Sentinel-2. This is the data that we used. Some of the images, we compare these images with another public dataset only to validate with better resolution. For instance, the Google images could have a very high spatial resolution, but we don't train with that kind of images. Only used to validate with the human this kind of images.
Okay.
And the images are multi-channel images, which is another problem in deep learning, because usually you only work with 3-channel images, and we have to select the best 3 channels to solve this problem.
Do you how frequently do you take pictures?
Okay, it depends of the sensor. Usually, the most frequently is for a period of a week. Yes, but we don't use this kind of images. We perhaps you know that in Mexico will be in the summer a lot of clouds. Yes, this is a big problem with this kind of images. So we select images, for instance, from this month, March, because we don't have clouds in the images, and we select 1 month per year, and to try to avoid the clouds.
Okay, so you only work 1 month a year.
Yes, yes, and this is mostly because the plants takes 7 years to be mature, to be ready to the tequila, and we believe that one year images could be enough.
Okay, cool. Hey, I see, John, you've got a question. Do you want to ask it directly? Well, John, you're on mute, or your microphone is not plugged in. I can't hear you, John. John, we can't hear you. Or is it me? Eduardo, do you hear John?
No, I can hear John. I only heard you, John. Jean?
Yeah. Hey, John, maybe you can type your question if you've got a microphone problem. Okay, it's here. Okay, I'm also curious about what would be the limitation of such a tool. Can you elaborate a little bit, or?
Yes, yes, of course. We have some limitation, mostly with related with the sensor. This is constantly improvement by the industry, better images and these kind of things. But right now, we isn't mostly impossible to detect agave crops from before 2 years. Yes.
Okay.
So it's not possible to say, oh, this is a crop, or perhaps could be, I don't know, corn on other kind of yes, of crop. It's difficult to say that. Another limitation that I believe that is important is the image quality, or perhaps the plant quality, because some plants are very I don't know, have problems, health problems, and it's difficult to get this to segment these images. And finally, the other limitation is that we need in deep learning is usually needed that a lot of data, yes, and different data. So we start to increase the label data set, I'm sorry, the training data set, the validation data set, and start to create an test data set. We need to improve this, but the preliminary results looks good, even with the images where the model never seen before. So this is some comments about the limitation of the agave detection. Yes.
John, did you find a way to talk, or? Yeah, I think we definitely lost John. Do you think this technology can be applied to other crops, or?
Yes, it's possible to apply to other crops, but the technique is different because we need to know some, as you suggest, a kind of time series information about the crop. Because usually the other crops are seasonal, and it's difficult to see only with the images at this resolution. So some additional information is needed. For instance, the time series. But then there is another problem with the cloud season, with the summer season, because we don't have images in that season. So to avoid this problem, we try to change the sensor, and we move to another sensor which not only detect the light. This is a radar sensor, which also is the source of the signal and detect the signal. Using this kind of sensor, it's possible to avoid the cloud problem, but of course, you get a new problems to clean the data and these kind of things, and helps a lot to get the time series information of the crop.
Okay.
Yes. Yes. So I want to thank you for the organizers for this big event, the P-Day. I want to thank you especially to Ralph for the invitation. And of course, if you want to come to Mexico, to Jalisco, drink tequila, please let me know. I can get some space to give you a tour from this in this state.
Yeah, I'm sure you will find a lot of volunteers coming to try the tequila. That's definitely. I have a question from Kat. She says, "Hi Eduardo, do you also use a similar technology to predict shortage in agave yields?"
Yes, we try to get this. So far, we made a segmentation only, and then with this segmentation, we need to connect with another kind of technology to get this kind of information, which is the final result of the project. We don't only want to segment the crop. Finally, we want to know if we need more agave, or perhaps we need to create a new politic rule or something like that to prevent that will be a lot of agave. Yes.
Okay, awesome. Well, so thank you so much, Eduardo. This was a very interesting presentation. I loved it, and I think I'm not the only one. Not that the other one were not good, but we're perfect. So this was great.
Artificial intelligence,
Data. Analytics.
User group.
AIDAUG.
Join AIDAUG today.